Pennsylvania, my dear. Biden may have won the election, but the real winner of this election is Vladimir Putin. Okay, so please pause this video and read all this. I'm in a time constraint, and this is due to that. So we have our givens. So delta V, or the change velocity, is 25 meters per second. It goes from 25 to 0. Delta S is 55 meters since the truck is 55 meters from the hole. So for parity, we have to answer: can he stop the truck before it falls into the hole? This is physics, so we have to assume it can first. So as you can see, I made a free body diagram. So first we have to set the kinetic friction force equal to the mass times acceleration, the mass of the truck specifically, and the acceleration of the truck. We can't really calculate the mass, but we're only looking for acceleration at the moment. So yeah, and in order to do that, we are given velocity and position, but we aren't given time. So that means we have to use this equation, like this kinematic equation, where delta v squared equals two times the acceleration times delta s, or you can use delta x if you want to. So anyways, let me just algebraically manipulate the variables. So I'll cut this delta s, and then I'll paste it here. So you just divide delta s by both sides, and now divide 2 by both sides, and you have your acceleration function. This will make your calculations more accurate, since you're just gonna plug it in instead of just like dividing it by a certain value, which will be different due to significant digits. But anyways, this will be your acceleration. Equations. So anyways, what we are doing is we are solving part 10. To do that, we have to get that point where the nose of the car touches the edge of the hole. So basically, the mass times acceleration. That's where the mass times acceleration is equal to the friction force. Um, and this will assume that the car is at rest. So this will be like the maximum of that the truck can go before it falls to the hole if it goes over. So yeah. So we can't calculate mass anyways, but we can calculate acceleration. So we already have our acceleration function, and that is just 25 squared, since the velocity is 25 meters per second, and then delta s would just be 55 meters, since that's what's given. And now if you calculate this, that will that will that will be your answer for the acceleration. So okay, so I calculated that 5.7 meters per second squared is the acceleration of the car, of the truck, excuse me. Um, so anyways, in order for the truck to stop, like right at the hole before it falls, you have to get that the kinetic friction has to equal mass times acceleration, which we calculated as 5.7. So that's your answer for part A, and that's the only way that the car can stop before it falls into the hole. And now for part B, we answered yes. So can we stop the antique from sliding without being damaged? So in order to do that, we have to get the we, we look here and it says without the antique sliding. So that will indicate that the antiques would have to stay still. So in order for the antique to stay still, we have to calculate static friction. The difference between kinetic friction and static friction is that static friction is what keeps objects still, and kinetic friction is what goes against moving objects. So yeah. We have here that the static friction has to be greater than the mass times acceleration. I already calculated as 5.7. I'm just too lazy to put it back in. So we have an equation for static friction, and that static friction equals static coefficient of friction times normal force. So we have mu subscript s, so that's 0.60. Well, we do not have f of n. However, we do know that from deduced from the free body diagram, f of n, normal force will equal gravitational force, only because the truck is not moving in the y-axis. So that would mean that the two forces have to be equal, since they both equal 0. So f of n will equal mass times gravitational acceleration. Gravitational acceleration we know is negative 9.81 and meters per second squared, and not 10. So after that, we plug this in for f of n, and then we get that 0.6 times the mass of 9.81 would be the function of static friction. So we need to plug in f of s for this function. So once we multiply this, it would just be negative 5.9 meters. And we're looking for acceleration, the acceleration of the truck needs to protect the valuables. So anyways, you set this equal to mass times acceleration. The mass is cancelled on both sides, and you have your answer. So the acceleration has to be less than or equal to negative 5.9 meters per second squared in order to protect in order to protect the valuables and your knees.